In the past few weeks, we have learned how to take raw data, for example, the serum zinc dataset available in your content section, and make some type of graphical representation so as to make sense of that data. What do we mean by making sense? Well, one way of making sense of data is to demonstrate the typical score of a distribution, or central tendency, the mean, the median, or the mode. Here we have a box plot, in which the box defines the first and third quartiles of the zinc distribution. And the line in the center demonstrates the median, or the 50th percentile. In this histogram, we can see how the concentration of zinc clusters around some typical score, and then flattens out as we travel to either side of the distribution. We can also use our software program to calculate the mean of the distribution, but knowing the mean or demonstrating the mean on a graph is not sufficient to truly understand the nature of the distribution. That's where measures of variability come into play. Standard deviation, one of the most common forms of calculating variability, gives us a sense of how far scores tend to vary from the mean. In fact, when we consider the classic bell-shaped curve, also known as the normal curve, and we calculate 1, 2, or 3 standard deviations from the mean, we can capture a certain percentage of cases around the mean. Why is that important, you may ask? Well, this week we are going to examine the concept of determining a confidence interval. What is a confidence interval? A confidence interval is a technique that provides a range of reasonable values that are intended to contain the parameter of interest, in other words, the population mean. That is the focus of this week's exercises, as they provide us the final steps towards hypothesis testing.